sketching the curve of this third-degree polynomial using a bunch of details like the domain of the function, x-intercept and y-intercept, vertical asymptote, horizontal asymptote, local minimum and maximum, concavity, and inflection point. So let's start with the domain. So since this is a third-degree polynomial, so the domain of f, so what's the domain of a third degree or higher degree polynomial? That is all real number, right? So x can be any number you like. And then how about the x-intercept and the y-intercept? This is a lot of homework, so make sure you have enough space on your paper. So let me use different colors to divide this up. So for y-intercept, we let x equals to 0. So x equals to 0, then you have y equals to 0 plus 0 plus 0, right? Minus 27 equals to negative 27. So your y-intercept is x equals to 0, y equals to negative 27. Negative 27, this one individual number is not a y-intercept. You have to use a coordinate, x coordinate and y coordinate. And then x-intercept, so x-intercept, then this time you let y equals to 0. You solve for x, so when y is equals to 0, you have 0 equals to negative x to the third plus 3x squared plus 9x minus 27. And then since we have a fourth term, this is a four terms, this is a third degree polynomial, then we will do factor by groups. All right, factor by groups. So factor by groups, I am going to group the first two terms and the last two terms. I will just do it right here, so I can save one line. I will group the first two terms and the last two terms. So since this is a plus, there is no need to change the minus 27. All right. And then the first factor, we are going to take our negative x squared. So we have x plus minus 3. So we have a x minus 3. And then plus factor our 9. And then x minus 3. So since they both have x minus 3, so we are going to factor out x minus 3, and then we have negative x squared plus 9. And then for the negative x squared, before I factor that, I will pull a negative 1 out, so x squared minus 9, and then pull the negative 1 out, so this becomes x minus 3. The x squared minus 9 becomes x plus 3, and then x minus 3, and then we have a negative 1. The negative 1 is not important because once we divide both sides by negative 1, the negative 1 is gone. So we know that x equals to 3 and x equals to negative 3. So we have two x-intercepts. The first one is 3 comma 0. The second one is negative 3 comma 0. So the x-intercept is done. And then the next step, let's move on to vertical asymptote and horizontal asymptote. So since this is a third degree polynomial, what do we expect? What's the graph look like for polynomial? So for polynomial, the graph will be just some curve, right? So since this is a third degree, so third degree polynomial, this is not a rational function, so it doesn't matter what x value you choose, you will never get a 0 in a denominator, right? So there is no vertical asymptote. So we do not have vertical asymptote. And then what about horizontal asymptote? So this horizontal asymptote, and then as x approaches to infinity, y approaches to infinity, right? So there is no horizontal asymptote as well. And then x approaches to negative infinity. This one as x approaches to infinity, so if you plug in negative infinity, y approaches to positive infinity. And then the first one, let me fix that. Let me fix that a little bit. As x approaches to positive infinity, y approaches to negative infinity. So just simply plug in a positive infinity to the polynomial. So this one, you don't really need to mention this. Just say there is no horizontal asymptote. This is a polynomial. Or, okay, here, this is what you can say. How about this? Just get rid of this. So this is a third degree polynomial. You can just say there is no vertical asymptote and no horizontal asymptote. That is done. So no HA and then no VA. And then the rest, we will be finding the maximum and minimum. Then you will be using the first derivative. So we are going to take the first derivative. Let me use color to divide this up. So we are moving on to maximum and the minimum, right? So let me change this to another color. So we have f prime of x, so that is equals to negative 3x squared, and then plus 6x, and then plus 9. You have to set that equals to 0. Do not use the second derivative test. This one you have to go through the sign chart. Use the first derivative test. So you set that equals to 0. And then this one, before I factor, I will take a negative 3 out. So I have x squared minus 2x minus 3 equals to 0, negative 3. And then factor that x plus 1, x minus 3. So that is equals to 0. So we have x equals to negative 1 and x equals to 3. They are my critical numbers. All right, they are my critical numbers, and then you have to use these critical numbers to set up your test interval. So we have a number line, and then we have a negative 1, we have a positive 3, so that creates 3 test intervals from negative infinity to negative 1, from negative 1 to 3, and then from 3 to positive infinity. And then the next step is you have to grab a number within every single interval. So let's say x equals to negative 2, x equals to 0, and x equals to 4. And then you are testing, you are analyzing the slope, right? So that's why you have to plug in the test value to the f prime. So f prime of negative 2, f prime of 0, and then f prime of 4. So this one, f prime of negative 2, you have a negative 15, 0 gives you a 9, and then 4 gives you a negative 15. Again, we are analyzing slope. When you're analyzing slope, you have to ask f prime to do the job for you. So that's why you plug this into f prime. So negative f prime, that means the slope is going downhill, positive means going uphill, and negative means going downhill. So from down to up, when x equals to negative 1, we have a critical number, and there is a horizontal tangent line. So that means here is a minimum, and then here is a maximum. This is at x equals to negative 1, a maximum at x equals to 3. And then to find out the exact location, you have to do this because you need to do the graph. F of negative 1 and then f of 3. So you are looking for a point on the curve of the given function, then you have to plug it into the given function. So f of negative 1 gives you a negative 32, f of 3 gives you a 0, so your relative minimum is negative 1 comma negative 32, and then your relative maximum or local maximum is 3 comma 0. We are pretty much done. The second derivative, in my opinion, in this problem, we don't really need the second derivative because at this point, we already have enough information to do the graph. Since you might see a problem where they subdivided this into little steps, so let me do the second derivative as well. I will switch to a different color. So second derivative, let me do the second derivative right over here. So the second derivative, so based on the first derivative, the second derivative, you bring the 2 down. So you have a negative 6, right? You have a negative 6x and then plus 6. Okay, so you set that equals to 0. And then when x is equals to 1, we have a 0, right? So that means x equals to 1. So this is my critical number. And then we are using this to find the concavity. So draw a number line. When x is equals to 1, we have 2 test intervals from negative infinity to 0. Sorry, not to 0. From negative infinity to 1, from 1 to positive infinity. And then grab a number within each test interval, x equals to 0, x equals to 2. And then you are testing this x using double prime because you are analyzing concavity. Double prime of 0, double prime of 2. So double prime 0 gives you a 6, 2 gives you a negative 6. So positive 6 is positive. So this is positive. This is negative. By the way, back to the previous problem. This is negative. This is positive. And then this is negative. Negative is downhill. Positive is uphill. For concavity, positive is concave up. Negative is concave down. And then from concave down to concave up, you have an inflection point at x equals to 1. So where is this point exactly? You have to ask your original function. So f of 1, so that is equals to negative 16. Then the inflection point is 1 comma negative 16. So now we already have all the information to sketch the graph. So for the graphing part, I'm going to do this in a different color. So let me do it in green. So this one, let's sketch the x-axis. So this is my x-axis. And then let's draw a longer y-axis. So this is my y-axis. So first of all, we have a two x-intercept. Just look at your paper. We have two x-intercept, one at -3 and then one at +3. So this one is a -3 comma 0. This one is +3 comma 0. And then we have a y-intercept. Where is the y-intercept? The y-intercept, so if you take a look at the step that you just did, is at 0, -27, right? So when x equals to 0, y equals to -27. So that is somewhere over here. So when x is equals to 0, y is equals to -27. And then what else do you have? You also have a local minimum, right? At -1. So when x is equals to -1, y equals to -32. So that point is right over here. -1, -32. And then the other point we have is our maximum at 3 comma 0. So now let's sketch the graph. So this is a minimum, right? And then this is a maximum. And then you go back and take a look at your sign chart. So we go down, up, down. All right? Down, up, down. So here is how we do it. We go down, up, and down. So that's how we get the min and max. And then one other thing is the inflection point. So when x is equals to 1, right here, so when x is equals to 1, y is equals to -16. So this is 1, -16. That is my inflection point. And then this one goes all the way down, right? So it should go down like this. So going down, up, down. So that's how we get the min and the max. So if you use your graphing calculator or decimal to graph this function, you will get the same thing. Okay, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share this video in any social media for me, feel free to do so. If you are new to the channel, please take 2 seconds to click the subscribe button down below. I promise it is worthwhile coming back. I will see you all in the next lesson. Signing out.